Okay, this video will be on the practice worksheet that we did in class. Okay, on the first example, we are asked to find the bounded area. So let's go ahead and make a sketch. We have a parabola, and then we have the line y equals negative x. And it wants to know, well, what is the area between the regions x equals 0 and x equals 2. So we're looking for this region here. So let's go ahead and write out our area. It's going to be from endpoint to endpoint, so from 0 to 2, of our top function minus our bottom function. And since this is multiple choice, we do need to go ahead and finish working this out. Let's see, that's going to end up being x cubed over 3 plus x squared over 2 evaluated from 0 to 2. So now we need to substitute in our endpoints, and it looks like we're going to have 8 over 3 plus, let's see, 4 over 2 minus our bottom endpoint, which is just going to generate a 0. So I have 8 over 3 plus, of course that cancels out to be 2, so we're going to have 6 over, 6 over 3. So that's going to give us 14 over 3, which looks like it's answer choice D. And for number 3, and we are skipping number 2, number 3, we have the graph of y equals x squared, and we have the graph of y equals 2. So our bounded region is in here. We are rotating about the y-axis, so we are flush with our axis of rotation. Our point of intersection here, this line was y equals 2. This was y equals the square root of x. So here my ordered pair should be 4, 2. So let's do our integral. But we're rotating with the y-axis. So our x, or our y equals square root of x, that needs to be changed to x equals y squared. We have to go over to terms of x equals. And up over here we are bounded with our axis of rotation as x equals 0. So that's going to be okay. So we are going to integrate from 0 to our y coordinate of 2. And our r here, we won't have a little r, but we will have a big R. And that's going to be from our function to the axis of rotation. We always do right to left. So our right function here is going to be y squared dy. There's no little r. So, and then of course we have pi. So pi times, this is going to be y cubed over 3, evaluated from 0 to 2. And when we substitute in, notice we're going to get pi times 8 over 3 minus 0. So it looks like we have answer choice D. Okay, the next problem is an area problem. So again, we are going to sketch this. So we have the graph of x squared plus 1. So that does mean our parabola is moved up 1. And then we have the line y equals 5. So our bounded area that we're looking for is inside here. And we need to reach from endpoint to endpoint. So we do need to see what those endpoints are. So we do need to set our two functions, the y equals 5 and y equals x squared plus 1. We'll set those equal to each other and solve. And notice we have x squared equals 4, so x is plus or minus 2. So there's our two endpoints. So now for area, we integrate from endpoint to endpoint, and it's going to be our top function, which was 5, minus the lower function, which is x squared plus 1. And so we have our integral from negative 2 to 2. And we're going to have, looks like negative x squared. And then we're going to have plus 4 dx. And now we're ready to integrate. All of this other stuff we have not integrated yet. So we have negative x cubed over 3 plus 4x, and we are evaluating this from negative 2 to 2. So if we plug in 2, our top end point, we're going to have negative 8 thirds plus 8 minus our other, let's plug in the negative 2. So that's going to give us a positive 8 thirds minus 8. So when we combine our terms here, it looks like we're going to have negative 8 thirds minus 8 thirds, so that's negative 16 thirds plus 16. And that 16 as a common denominator, well, we need 3. And so on the top, we're going to have 48. So it looks like we're going to have 32 over 3. And let's see what answer choice that is. That's going to be answer choice D. Okay, for number 5, we are going to look at the graph of secant. Now for secant, we probably don't remember what secant looks like, but we do most of the time remember that cosine looks like this. And secant being the reciprocal means that on top of these heels, our function is flipped over. So really, there's what the secant function looks like. It really looks like a parabola. And then we are cutting this at pi over 3. And so we're talking about this area here being rotated about the x-axis. So when we do that, then we are going to integrate from 0 to pi over 3 of secant x dx. And so if we integrate secant, that one is going to be a little bit strange. It's just a formula. Oh, and I forgot my pi. Sorry, folks. So it's going to be pi times the natural log of the absolute value of secant x plus tangent x. And again, that's just a formula. We are evaluating from 0 to pi over 3. And so here when we start subbing in, we do have pi times the natural log, the absolute value. Well, secant of pi over 3 is going to be 2 plus tangent at pi over 3 is the square root of 3. And so there's my top endpoint minus the bottom endpoint, which is going to be natural log. Absolute value of secant at 0 is 1 plus tangent at 0 is 0. So when we finish this, we do have pi times the natural log, and that's going to be a 2 plus square root of 3. We know that's a positive value. Minus, well, the natural log of 1 is 0. Now this answer does not match what we're seeing. It's pretty close to E, but that's because these answers are written from using the shell, I believe, method. So because this is a very old question, but this would be the final answer. For number 7, again, we are finding the volume, and this time we are rotating about the x-axis. And we have, and this is very similar to when we just worked out on the previous page. We have the square root of x, so y equals square root of x, and then we have the line x equals 3. So here x equals 3. And so we're going to take this bounded region and we're rotating it about the x-axis. So we do need to set up here, and it doesn't look like we're going to have a little r. It looks like we are flush with our axis of rotation. So we just have big R. So our volume is going to be pi times the integral from 0 to 3 of the square root of x dx. And so, square root of x squared. So our volume is going to be pi integrated from 0 to 3 of x dx. And so, of course, we need to integrate. So we have x squared over 2 pi times this, integrated from 0 to 3. And so it finally looks like we're going to have pi times 9/2. So that should give us answer choice C. Okay, our next problem, we are finding volume, and we have the graph of y equals x plus 1 all raised to the 1/3. So we're looking at the cube root function. And let's see, cube root does something like this. That's just the general function, but in here, let's see, it's been added once, so we need to slide that over. So the cube root here, so that 0 is slid over, and it does something like this. And we're taking that and slicing out x equals 7. So here we have x equals 7, and we need to rotate this solid boundary here. We are rotating that about the y-axis. So we have to set up, but we're not solving. Now we do need to rewrite some things, because since we are going along with the y-axis, one thing we need to know would be, well, what's this ordered pair up here? I know x is 7, and so here we would need to plug in, and we have y equals 7 plus 1 raised to the 3rd. So that's going to be 8 to the 1/3, or the cube root of 8, which is 2. So now I know an endpoint that we'll be integrating. And then let's see, it looks like since we've moved that over 1, we're going to have a hole in our graph. So we're going to have big R's and little r's now. And let's see, we also need to swap over this function. I almost forgot to do that. So we have y equals the parentheses x plus 1 raised to the 1/3 power. We need this to say x equals. So I will cube both sides to remove my exponent, and then subtract 1. So I have y cubed minus 1. That's equal to x. Now I have my two functions written in the right form. So here's our axis of rotation way over here. And so to find big R, that's going to be from here all the way over to here. That's big R. And the reason why is because this x equals 7 is one of the binding parts of our area. And so that is farthest away from the axis of rotation. So big R is going to be 7. Now we have to find little r. And little r is going to be from here to my x plus 1 all cubed over to this axis of rotation. So little r is going to be, and we have to get our rewritten part, so it's y cubed minus 1. And now that we have those values, then we're ready to write our volume. It's going to be pi times the integral, and we have to go for our y endpoint, so we're going to go from 0 to 2. And then it's going to be our big R squared, so 49 minus our little r squared dy. And notice the answer is not there because all of those answers are once again in the form of a shell method. So this would be your final answer. So again, unfortunately, it's not matching what we have. And again, that is because you've done it correctly. It's just those answers are in terms of the shell method, which is no longer used. All right, so now we have the curve y equals sine of x. So it's going to look something like this. And then we also have the curve y equals 1, which is just going to go tangent to the top of our sine curve. And so here, notice that the bounded region is going to be sitting inside here. So this is going to be what gets rotated about the x-axis. So knowing that, that means we are not flush with that axis of rotation. So we are going to have to define big R and little r. So big R, I didn't finish this. Okay, so big R is going to be from my axis of rotation all the way, from the top function all the way down to our axis of rotation. So big R is 1. Little r, however, is going to be the function closest to that axis of rotation. So that's going to have to be my sine function. So here I'm going to get sine of x. So now we're ready to write our volume. Our volume is going to be pi integrated from, and it told us from 0 to pi over 2. And we're going to have big R squared. So big R squared is going to be 1 minus little r squared. And so it looks like that's going to generate for us answer choice E. In our next problem, we are still finding volume, and we have the function x squared plus 1, and then we also have the function y equals 5. So notice that we are going to be looking at this bounded region here, and so if we're rotating about the y-axis, we are going to have to change our y equals x squared plus 1. So if we rearrange this, that's going to become x equals the square root of y minus 1. And we already really have our endpoints given to us. We know from here that y value is 1, all the way up to this y value, which is 5. So now we're ready to integrate. Volume is going to be pi times from 1 to 5 of the square root of y minus 1, all squared. Again, we don't have a little r because we are flush with our axis of rotation. So we really only have that one big R, and you do right to left when you're setting this up. All right, so if we square that square root, that does cancel out all of that. So we have pi times the integral from 1 to 5 of y minus 1. And so when we integrate that, we're going to have y squared over 2 minus y, evaluated from 1 to 5. And so we have pi times. If we substitute in 5, we're going to have 25 over 2 minus 5. So there's our top endpoint minus the bottom endpoint. So the bottom, if I substitute in 1, we're going to have 1/2 minus 1. And so we have to keep going with this awesomeness here. So we have 25 halves minus 1/2, which is 24 halves. And negative 5 minus a negative 1, so that's going to be negative 4. And so that's going to be 12 minus 8, or 12 minus 4, which is 8. So it looks like we got an answer of 8 pi. So that's going to be answer choice B.